In this video, we're going to talk about pre-algebra. We're going to go through a typical pre-algebra review, going through all the different types of questions that you might encounter when you're doing a pre-algebra course. We're going to go step by step. You might want to try and pause the video and do some of these questions on your own and then compare with what I go over with you here in this video. We're going to be going through 82 different questions. If you have any questions about any particular problems that I'm doing in this video, I have additional problems like this on my Math Tutoring YouTube channel so you can get some more practice there. But let's jump into this video. The first question, how would you simplify this expression? 14 plus 4 divided by 2, all divided by 9 minus 2 times 3 plus 1. So what they're testing us on here is the order of operations. So you remember the PEMDAS, the parentheses, exponents, multiplication, division, addition, subtraction. So there's 4 levels of importance about what you want to do first, second, third, fourth. There's not any parentheses, so we can't do any of that. There aren't any exponents, so we're going to go to multiplication and division. 4 divided by 2 is 2, so we have 14 plus 2. 2 times 3 is 6, so we have 9 minus 6 plus 1. So now we've gone all the way down to addition and subtraction. We're going to do the numerator, 14 plus 2, which is 16, and then the denominator, 9 minus 6, which is 3, plus 1, which is 4, and 16 divided by 4 is 4. So that's how you want to do it. You want to treat the numerator and the denominator kind of separately, and then follow the order of operations. So definitely something important to review. Number 2, translate into an algebraic expression 3 less than the quotient of some number and 5. Okay, so how do we do this one? Well, the quotient means divide, some number and 5. We don't know what the number is, so we're going to say n divided by 5, but we want 3 less than that, so minus 3. So that's your final result. Now, some students mistakenly will see 3 less than, and they'll write 3 minus, because they're thinking about doing like a direct translation, like whatever comes first you write on the left, whatever comes second you write on the right, etc. But in this case, when you take 3 less than, you're actually subtracting at 3 from this quantity, so you want to be careful with the order there. Okay, for number 3, it says name the property shown. So 2 parts, A and B, but for A we have 2 plus 3 plus x, the quantity, equals the quantity 2 plus 3 plus x. Now notice that the 2, 3, and x are in the same order on the left side of the equation as they are on the right. The only difference is that here you have the 3 plus x grouped, and here you have the 2 plus 3 grouped. So what would you call that property? Well, this is called the associative property of addition. So I'm just going to abbreviate, associative property of addition. And the idea is associate is like you're grouping, okay? Just like your friends, you know, you associate with certain people. Here you're doing this group first, here you're doing this group first. The 2 sides of the equations are going to be equivalent. That's called the associative property. Now for letter B, we have 5 times 3y equals 3y times 5. Now notice how the order has actually been changed. What do you call that property? This one's actually called the commutative property. So when you change the order, that's called commuting. Okay, commutative property of multiplication. So I'm just abbreviating there. Okay, let's go over to number 4. Now this one says, graph the points on the coordinate plane. So we have A, B, C, and D. How would you plot these on the coordinate plane? Well, remember when you work with these coordinates, it's like an alphabetical order. It's like X, Y, Z. So the X controls left and right. Y controls up and down. Usually I do the X first, so -2 means I'm going to go left 2 from the origin, so left 2 from the center point here, and then I'm going to go up 3 because that's positive 3. So just remember, left is negative, right is positive, down is negative, up is positive, and so that's going to be point A right about there. For letter B, we've got 4, -1. So again, the X is 4, so we're going to start at the origin, right 4, and then Y is -1, we're going to go down 1, that's B. Now keep in mind that this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. You go in a counterclockwise fashion. For point C, 0, -2, sometimes this tricks students when the x-coordinate is 0. 0 means you're not going left or right, you're just going down 2. So that's going to be point C. And then for point D, -1, -4, you're going left 1, and then you're going down 4 because the y is negative, that's point D. Number 5 is very similar to number 4. The only difference here is it says write the ordered pair for each point. So here they're giving us the points, we have to write the coordinates. How would you do this one? Well, let's see, for point W, we're at 0 left or right, so that means the x-coordinate is 0. and then we're going up 1, 2, 3. That's our y coordinate. For point x, we're actually going right 3, that's positive 3, then we're going down 1, remember down is negative. Okay, for letter y, point y, how would you find the coordinates for that one? You're going left 2, so that's a negative 2, and then you're going up 1, that's a positive 1, and you've got it. Okay, for number 6, it says, does the scatter plot show a positive, negative, or no correlation? So what do you think for this one? When you look at these data points here, is it showing a positive, negative, or no correlation? Well, notice it's trending down to the right very clearly like that. If you were to draw a line of best fit, it would be somewhere in that region there. And because it has a negative slope, or it's decreasing as you go to the right, this is actually called a negative correlation. If it was trending up to the right, that's positive, like a positive slope. And if they were kind of scattered, there's not really a trend at all, then we'd say relatively no correlation. Okay, number 7, we have the absolute value of -4 minus the absolute value of -2. How would you do that one? Well, now remember, a lot of times students get confused with the absolute value. The absolute value, what you do is you treat it like parentheses. You do whatever's on the inside first, and then the end result is going to be positive. So the absolute value of -4 is just 4. The absolute value of -2 is just 2. And we have 4 minus 2, which just equals 2. Some students mistakenly think the absolute value means make it the opposite. That's not right. The absolute value is going to end up making the end result positive. Okay, so for number 8, we have, is it less than, greater than, or equal to? And you can remember this because the less than kind of looks like an L tilted. So this is less than. It points to the smaller quantity and it opens to the larger quantity, okay? So in this case, -4, is it less than, greater than, or equal to -3? Now sometimes it's helpful to draw a number line. So here's -4, here's -3, -2, -1, 0, right? So what happens is it looks like 4 is bigger than 3, right? But -4 means it's a larger negative number, which means it's further to the left. Okay, so it's actually smaller. So -4 is less than -3. Okay, and that's how you do that one. Number 9, we're evaluating, and here what it's talking about is having us practice our positive and negative numbers, adding, subtracting, multiplying, and dividing. Sometimes this is a little bit of a sticking point for some students, so you might want to review this concept. But for letter A, what do you think for this one? -15 plus 7. Well, this one's going to be -8. And the reason is like, imagine if you're walking backwards 15 steps, and then you walk forward 7 steps, you're further back by 8 steps from where you started, right? For letter B, we have -6 minus -8. Now, what you can do when you're subtracting is you can think of it as adding the opposite. So if you change a subtraction problem into an addition problem, you have to change that second quantity to the opposite sign. So if it's positive, you make it negative. If it's negative, you make it positive. But -6 plus 8, again, we have you walk backwards 6 steps, then you walk forwards 8 steps. You're actually 2 steps further ahead than from where you started. For letter C, you're multiplying now. So -4 times 3 would be how much? -12. Remember, when you have a negative times a positive, you get a negative. If you multiply 2 negatives together, you get a positive, okay? So just remember, if the signs are opposite, you're going to get a negative. If they're the same, you're going to get a positive. Okay, and for letter D, -64 divided by -8, the rules for multiplication and division are the same. If you have 2 negatives, you're going to end up with a positive. So 64 divided by 8 is 8. A negative divided by negative is a positive, and you got it. So go ahead and review the positive and negative numbers if you need to do that. I've got some videos on my channel to help you with that. Number 10, we've got right as a decimal. So we've got a fraction 4/3. How do you convert that to a decimal? What do you think? Well, when you look at this fraction bar, see that 4 divided by 3? That fraction bar just means divided by. So it's 4 that's being divided by 3. 3 goes into 4 once. 1 times 3 is 3, okay? And we can put a placeholder 0, okay? And we can bring this down. 4 minus 3 is 1. 3 goes into 10. How many times? 3. We bring up our decimal point right on our division bar there. 3 times 3 is 9. 1. Bring down another 0. 3 goes into 10, 3. And you can see it's 1.33333 repeating. So we could write this as 1.3 and put the bar over the 3 to show that it repeats. Okay, for number 11, it says write as a fraction or a mixed number. So 2.36, how would we write this as a fraction or a mixed number? Well, one way to do this is if you pronounce this in the correct fashion, it'll tell you how to write it. It's 2 and 36 hundredths. So you see how I did that? 2 and 36 hundredths. So whatever that last places for the decimal. This is the hundredths place. We have 36 hundredths. That's 36 over 100. Now we can reduce this a little bit. 2 goes into 36 18 times. 2 goes into 150 times. Okay, and then we can reduce it again. 2 goes into both of these, so that would be 9 and 25. So this is 2 and 9/25. You can check your answer. If you do 9 divided by 25, you're going to get 0.36, so you can see 2.36. For letter B, though, we've got a repeating decimal. How do we write this repeating decimal back into a fraction or a mixed number? Well, there's a little technique that you learn like when you're studying pre-algebra, and there's other ways to do this, but let me just show you. Say that you make your number equal to 2.7 repeating, so 7, 7, 7, dot, dot, dot. If we multiply both sides of this equation by 10, this would be 10 times n equals, and if we multiply this by 10, you're just moving that decimal one place to the right, that becomes 27.7777 dot, dot, dot. What you can do then is if you subtract 10n minus 1n is 9n, here you can see the 7 repeating portion is canceling, 27 minus 2 is 25, and if we divide both sides by 9, you can see that our number is actually 25/9. And that's going to be your fraction. Now you can also write this 9 goes into 25 how many times? 2 with 7 left over, so it's 2 and 7/9. And again, you can divide these and show to yourself that you're getting 2.7777, etc. Okay, number 12, it says identify to which set the number belongs. So we've got A, B, and C, -3, square root of 2, and 4/5. And just a quick refresher, there's different types of numbers. We have the real numbers, okay, which are most of the numbers that you're familiar with. These are not including the imaginary numbers. Imaginary numbers are when you take the square root of a negative number, but you usually get into that when you get into Algebra 2. So all the numbers are going to be in the set of real numbers. And then there's a split. It can either be rational or irrational. So you can see rational are these groups, irrational is the ones in these groups. But remember, rational means like a ratio, anything that can be written as a fraction of an integer divided by an integer. Now you might be saying to yourself, well, Mario, what's an integer? Well, an integer is any round number like -3, -2, -1, 0, 1, 2, 3, etc. So it can be negative, 0, or positive, but it couldn't be 3.5. Okay, that would not be an integer. And then we have the whole numbers, and the whole numbers are just from 0 and then the positive integers, 1, 2, 3, 4, etc. So let's see if we can do these. So -3, what set of numbers would that be in? Well, you can see it's going to be a real number, so I'll just write real. And it's also going to be a rational number because it can be written as a ratio of -3 over 1, so that's rational, okay, ratio. And it's an integer because you can see it's -3. But is it a whole number? No, because it's not 0 or one of the positive integers. Okay, let's go to square root of 2. So square root of 2, is it real? Yes. Okay, is it rational or irrational? Now, can it be written as the ratio of an integer divided by an integer? Well, square root of 2, if you do this on your calculator, it's going to be like 1.4 dot, dot, dot. It doesn't repeat, it doesn't terminate, meaning it doesn't stop. So this one actually cannot be written as a ratio. So this is actually irrational. And then that's as far as we can go. Those are the only two sets that square root of 2 is in. And then for letter C, we have 4/5. You can see that this is, again, real. And it's rational. You can see it's a ratio of an integer over an integer, so we'll say rational. And is it an integer? No, you can see it's not a round number, -0 or positive. So that's it. That's the only two sets that that one's in. Okay, so for number 13, now we're getting into working with fractions. So adding, subtracting, multiplying, dividing, etc. with fractions and mixed numbers. So let's review this. So -2 2/3 times 4.5. How would you multiply those together? Well, what a lot of students like to do here is just convert these into improper fractions. You take the denominator times the whole number plus the numerator. So this is going to be well, ignore the negative for a moment here. So 3 times 2 is 6, plus 2 is 8. So this is 8/3, but the whole thing is negative. Okay. 2 times 4 is 8, plus 1 is 9. So this is 9 over 2. And we're multiplying these together. Now what you can do is you can multiply the numerators together, the denominators together, and then divide. Or you can reduce top and bottom, or on the diagonals top and bottom. So that's what I'm going to do. 2 goes in here once, 2 goes in here 4, 3 goes in here once, 3 goes in here 3 times. Now when I multiply across, I have -4 times 3 is -12. 1 times 1 is 1. Anything divided by 1 is itself, so we just get -12. So that's how you would work with multiplying mixed numbers. Now for number 14, we're dividing. Dividing is very similar to multiplying, right? So when you divide, you use the keep it, change it, flip it technique. So you keep the first fraction, you multiply by the reciprocal of the second fraction. But first we have to convert them into the mixed numbers into improper fractions. So 5 times 2 is 10, plus 3 is 13, so this is 13/5. The whole thing's negative. Okay, divided by 5 times 1 is 5, plus 2 is 7, 7/5. The whole thing is negative. But remember how we said that division is like multiplying by the reciprocal? So I'm just going to flip that over. And again, you can reduce numerator and denominator, okay, or on the diagonals numerator and denominator. So when I multiply across here, I'm just getting negative 13/7. I'm sorry, negative times a negative would actually be positive. And 7 goes into 13 one whole time with 6 left over. So this is actually simplifying down to 1 6/7. Okay, so now at number 15, we're getting into adding fractions. So when you add fractions, unlike multiplying and dividing, you have to have a common denominator. So what's the smallest number that 5 goes into and 10 also goes into? Well, they both go into 10, so it looks like 10 is going to be our smallest denominator. I'm going to multiply the top and bottom by 2 for this fraction. That gives us 6/10. So 6/10 is the same as 3/5. So 6/10 plus 7/10 is 13/10. 10 goes into 13 once with 3 left over, so it's 1 3/10. For number 16, we're subtracting mixed numbers. So let's first convert them into improper fractions. So 4 times 3 is 12, plus 1 is 13. So we have 13/4 minus 3 times 1 is 3, plus 2 gives us 5/3. Now we want to get a common denominator. It looks like 12 is the smallest number that 4 and 3 both go into. So to make this 12, I'm going to multiply the bottom by 3, but I have to do the same thing to the top. To make this one 12, I have to multiply the bottom by 4. I have to do the same thing to the top, because 3 divided by 3 is 1, 4 divided by 4 is 1. When you multiply by 1, it doesn't change the value of the fraction. So we get 39/12 minus 20/12, which is equal to 19/12. 12 goes into 19 once with 7 left over, right? So that's 1 7/12. Okay, number 17 is very similar to number 16. Here we're just adding two mixed numbers. Same process. See if you can do this one on your own. Again, you want to convert into improper fractions. So 3 times 5 is 15, plus 1 is 16 over 3. 5 times 2 is 10, plus 3 is 13 over 5. Common denominator looks like it's going to be 15. So I'm going to multiply the bottom here by 5 and the top by 5. Top by 3, bottom by 3. So 15 times 6 is 80 fifteenths, plus 39 fifteenths, which gives us 119 fifteenths. Okay, so now you want to go back and convert this into a mixed number here. So 15 goes in here about, let's see, I think 7 times. So that's 7 times 15 is 105 with 14 left over. So that's 7 14 fifteenths. Okay, and number 18, what we have here is they're testing us on the distributive property. So remember the distributive property. See how the -4 is right next to that parenthesis? They're side by side with nothing in between. That means that they're multiplied together. And so with the distributive property, you take whatever on the outside, you distribute it into the parentheses. And what you're doing is you're taking what's on the outside and you're multiplying it by what's on the inside. So -4 times 2x is -8x. -4 times -5 is a positive 20. When you see a minus sign, just think of it as a negative number. Group that together. So -5 times -4 is positive 20, which is like plus 20. And you got it. That's the distributive property. Okay, number 19, it says simplify. So you want to take this expression and you want to try to condense it down. So how would you do this one? 2x minus 5 plus 4x plus 8. So what you want to do is combine like terms. And what some people like to do is kind of like circle the like terms. So for example, you've got 2x and 4x. And here you've got, let's say, -5 and positive 8. So I put different shapes around the like terms that correspond with one another. So you can think of these on like little sheets of paper. You can move them around and group the ones together that are similar. So we've got 2x plus 4x, which is 6x. We have -5 plus positive 8, which is positive 3. And you've got it. Now all these are added together. If you see a minus, just think of it as a negative. If you see a plus, just think of it as a positive, but they're all added together. Let's go to number 20 now. So it says simplify this expression. So 3 times a minus 2 minus 4a plus 6. So how would you do that one? Well, here you can see we've got the distributive property. So we have to multiply that 3 into the parentheses. And then we'll bring down the -4a and the 6. Now we want to combine like terms. We've got 3a and -4a. So that adds up to -1a. And we have -6 and positive 6. That's actually 0. That cancels out. So it just comes out to -a. Let's go to number 21. Now, we're getting into solving some equations, and we've got basically like one step, then two step, then multi-step equations. So let's start off with some of the basic ones. Number 21, it's to solve x minus 4 equals 9. So we want to get the variable by itself on one side of the equal sign, on one side of the equation. We want to find out what x is. But to do that, you have to do the inverse or the opposite operation. So what I mean by that is instead of subtracting 4, to get rid of this minus 4, we have to do the opposite of subtracting, which is to add 4. If you do it to the left, you want to do it to the right to keep the equation balanced. You can kind of think of this as a line or a divider. These cancel. We get x equals 9 plus 4, which is 13. Now, the nice thing about algebra is that you can check your answer. If you take the 13, you put it back in for x, 13 minus 4, yes, that's 9, so you know you got it right. So let's go to number 22. So m plus 7 equals negative 2. We want to get m by itself. So that means we have to get rid of the 7. What's the opposite of adding 7? That's subtracting 7. Whatever you do to the left, you want to do it to the right. Keep the equation balanced. This comes out to 0. Those cancel out. Negative 2 minus 7 is negative 9. Again, if you want to check your answer, put negative 9 back into the original problem and check. Okay, for number 23, we've got a division one here. We've got e divided by negative 4 equals 7. What's the opposite of dividing by negative 4? Multiplying both sides by negative 4. So these cancel, and we get 7 times negative 4 is negative 28. Okay, now for number 24, now we have 9 times f. Notice they're right next to each other. That means they're multiplied together. What's the opposite of multiplying by 9? Dividing both sides by 9 to keep it balanced. So these cancel out. This just gives you f equals negative 3, and you got it. Okay, now we've got a little bit more of a two-step equation. Okay, so we've got x divided by 3 minus 5 equals 4. Now what I like to think about is we're trying to work from the outside in towards that variable. We're trying to get that x by itself. So working from the outside in, I'd probably get rid of this 5 here first. So instead of subtracting 5, I would add 5 to both sides. These cancel, so now we're just down to x divided by 3 equals 9. What's the opposite of dividing by 3? Multiplying both sides by 3. 9 times 3 is 27, and you got it. Now if you want to check your work again, you put it back in. 27 divided by 3 is 9. 9 minus 5 is 4. The two sides match, you know you got it right. For 26, same thing. We've got a two-step equation. Again, think about working from the outside in towards that variable y. How would you do this one? 2y plus 6 equals 4. If I was going to do it, I would subtract 6 first. So that's going to give you negative 2. And then I'd say, what's the opposite of multiplying by 2? Dividing both sides by 2. So we get y equals negative 1, and you got it. Okay, number 27, it says translate into an equation 4 less than the product of negative 2 and a number is 5. Okay, so how would you do that one? Well, let's take a look. So when you see the word product, that means multiply. Okay, negative 2 and a number. So we don't know what the number is, so we're going to make that a variable. So negative 2 times n, okay, and 4 less than that. So 4 less than the product, so that'd be minus 4, is, whenever you see the word is, that's equals 5. And that's your equation. Then you can go on to solve it if you want, but they just asked us to translate into an equation. So let's go to number 28 now. We're finding perimeter and area. Remember, perimeter is the distance around the object. Area is the inside of the object, right? So when we find the perimeter for this one, we're going to want to add up all the exterior sides as if you were walking around the outer edge of the object. So that'd be 4 plus 7, which is 11, plus 10, which is 21, and the units are just going to be centimeters because it's just like one-dimensional, just length. But if you want to find the area, since it's a triangle, we have to use the formula 1/2 base times height. Now the base is the bottom. This is kind of like what it sits on here, which is 10, times the height. That's the perpendicular distance. Okay, a triangle is kind of like a mountain. So imagine you climb the mountain. It's the shortest distance from the peak to the base. Okay, so that perpendicular distance. So that's going to be 10 times 3, which is 30, times 1/2, which is 15 centimeters squared. Okay, so area is going to be two-dimensional. You're filling it up with 1 by 1 centimeters square. Okay, for number 29, it says solve x minus 2 equals negative 3x plus 6. And this is a little bit more challenging equation because you have variables on both sides of the equation. But the key is to get the variables on one side and the numbers on the opposite side of the equation. So what I'm going to do here is I'm going to get the variables on the left, which means I have to get rid of them here on the right. Whenever you want to get rid of something, you want to do the opposite. So instead of subtracting 3x, what I'm going to do is I'm going to add 3x. This way the negative 3x and positive 3x cancel. So we're just left with 6 on the right, and 3x plus 1x is 4x,
minus 2. Okay, so now we want to get the variables by themselves. We want to get the numbers on the other side. So instead of subtracting 2, we're going to add 2. Okay, that way these will cancel out. And so now we just have 4x is equal to 8. Instead of multiplying by 4, we're going to do the opposite. We're going to divide both sides by 4. And so you can see x equals 8 over 4, which is equal to 2, and you've got it. Now if you want to check your answer, you can always put it back in, make sure the left side and the right side balance, right? Okay, so for number 30, we're getting into solving inequalities. Again, remember this is like L for less than, so 15 is less than negative 3 minus 2y. How would you solve that inequality? Well, it's just like solving equations. You want to get the variable by itself, but when you solve inequalities, you really want the variable to be on the left when you're completely finished solving the inequality. But to start off with, what we're going to do is we're going to add 3 to both sides because we want to get the numbers and the variables on opposite sides. Now here what I'm going to do is I'm going to get y by itself by doing the opposite of multiplying by negative 2. I'm going to divide both sides by negative 2. But what's interesting is when you multiply or divide both sides of the inequality by a negative quantity, this inequality sign actually flips. So instead of less than, it's going to become greater than here, and that's negative 9. Now the last step, again, like I said, is you want that variable on the left. So I'm going to take this whole inequality, I'm going to pick it up and flip it over so that the variable is on the left, the number is on the right. Now what we're going to do is we're going to go to the number line, we're going to graph this. So here's negative 9 right here, here's negative 10 right here, here's negative 8 right here. Now y is less than, so I'm going to make this an open circle, meaning it doesn't include negative 9, but it's all the values that are less than, meaning smaller than negative 9, so we're going to graph to the left. Okay, so this is a set of solutions, not just one answer, but any point less than or to the left of negative 9. Okay, so for 31, this is very similar. See if you can do this one. We've got 3x is greater than or equal to negative 12. Again, we just want to get x by itself, so instead of multiplying by 3, I'm going to divide both sides by 3. X is greater than or equal to negative 4. Now notice I didn't flip the inequality sign because I'm dividing by a positive number. Only if you multiply or divide both sides by a negative number does that inequality sign change direction. So here you can see it's greater than or equal to. Equal to means it includes this point. Greater than means as you go to the right. So negative 4, negative 3, all the values that are greater than or equal to negative 4. Okay, for 32, we've got a little bit more challenging equation to solve. See if you can do this one. But what I'm going to do is I'm going to start by simplifying the left side and the right side. So I've got 7x minus 7, just doing that distributive property. Here I'm going to combine like terms. Negative 2x and positive 9x is 7x plus 5. And then here what I'm going to do is I'm going to subtract 7x from both sides. Notice the variables are canceling out on both sides of the equation, and we're only left with negative 7 equals 5, which really doesn't make any sense. Negative 7 cannot equal 5. This is not true. So what this tells us is that there's no solution to this equation. Now, if it came out to negative 7 equals negative 7, or 5 equals 5, or the same thing equals the same thing, then it would be an infinite number of solutions. And then if we just ended up with x by itself and then equals something, then we would just have one solution. So this is kind of a special case when the variable cancels out. You have to see if it's always true or never true. Okay. And then number 33, it says write as a unit rate. Okay, so see that word unit? Unit means like 1. So we want to convert here $21 for 3 games. How much does it cost just for 1 game? And so what we can do is we can set this up as a ratio, $21 per means like divided by 3 games. But what we want is we just want how much does it cost for 1 game, right? Because that's 1 unit. So you can see here, how am I getting from 3 to 1? I'm dividing by 3. So if I divide the denominator by 3, I have to divide the numerator by 3. So that comes out to $7 per 1 game. So that's the unit rate. Okay, number 34, it says convert 20 feet per second into miles per hour. So this is what they call a unit conversion problem. How would you do this one? Well, what you can do is you can start off with what they're giving us, which is 20 feet per 1 second. And what we need to do is we need to make our way over to miles per hour. So let's start with the feet. We know that there's 5,280 feet in 1 mile. Now what's interesting is when you set up these conversion factors, see how the feet in the denominator cancel with feet in the numerator? So now we're just left with miles. So we're converting the units. But now we need to go from seconds to hours. So we know that there are 60 seconds in 1 minute.
Okay, notice the seconds in the numerator cancel with the seconds in the denominator, so you know you've set this up the correct way. If you set it up the other way, the units are not going to cancel that you don't want. And then again, we want to get rid of the minutes, so we know that there's 60 minutes in 1 hour. Again, notice the minutes in the numerator are canceling with the minutes in the denominator. You can see now all we're left with is miles in the numerator, hours in the denominator, so miles per hour is what we're left with. So all we have to do now is multiply all the numerators together, all the denominators together, and then divide. So let me do that on the calculator. So we've got 20 times 60 times 60, which is coming out to 72,000. So let me just write that down here. So 72,000, and then 1 times 5,280 times 1 times 1. And now all we have to do is just take that 72,000 divided by 5,280, and we're getting about 13.6, I'm rounding, miles per hour. So that's how you convert units using these conversion factors. Now for 35, it says, do the ratios form a proportion? What exactly is a proportion? A proportion is a ratio that's equal to another ratio, or like a fraction that's equal to another fraction. There's a couple different ways to do this. One way to do it is to see if you can reduce the fractions to lowest terms. If the two fractions are equal, then you know that it forms a proportion. The other way to do it is you can like cross multiply. You can multiply on the diagonals and see if that's the same as the product of the other diagonals. But in this case, I think I'm just going to reduce. So if I divide both the top and bottom by 4, I get 3/5. If I divide the top and bottom here by 5, that's going to give us 3/5, and you can see that 3/5 equals 3/5, so yes, this does form a proportion. Okay, let's go to number 36. It says, what is the scale factor if 3 inches represents 1 foot, right? 1 foot. So say you have like a blueprint, and like on the blueprint it says like 3 inches equals 1 foot in real life, but you want to know the scale factor, meaning like how many times larger is it, or how many times smaller is it? Well, the first thing we need to do is convert these units so that they're the same. So we know that 1 foot is actually like 12 inches. And what we're going to do is see, because the feet, that's like our new dimension, and the 3 inches was our original dimension, I'm going to take the new divided by the old. So 12 inches divided by 3 inches is actually 4. So you can see the scale factor is 4. It's like it's 4 times larger in real life. So just remember, new divided by old to get your scale factor, but make sure the dimensions are the same. For number 37, it says solve the proportion. Now, we've been talking about proportions here a little bit. There's two different ways, like I said. Like one way that a lot of students like to do it is just multiplying the diagonals. So 3 times 24 is 72, and that's going to be equal to this diagonal multiplied together, which is 18x. And now all you have to do is divide both sides by 18, and so that you can see that x is coming out to 4. The other way to do it is you could say like, oh, 18 divided by 6 is 3, so then 24 divided by 6 is 4. You know, that's another way to do it. But a lot of students just cross multiply, so I would recommend that method. So for 38, it says if 2 inches equals 12 feet in real life, so say again like that blueprint diagram that I was talking about earlier, what are the real life dimensions of a room that measures 3 inches by 4 inches? Okay, so there's a couple different ways to do this. One way to do it is to set up a proportion. You have the scale, which is 2 inches, to real life, which is 12 feet. And then let's say on the blueprint or the diagram, 3 inches equals x feet. And we could do the same thing over here. We could say 2 inches represents 12 feet, and 4 inches on the diagram equals, you know, x feet in real life. So if we go ahead and solve this now, let's cross multiply. We have 2x equals 3 times 12, which is 36. Divide by 2, x equals 18 feet. Here we have 2 times x equals 4 times 12, which is 48. Divide by 2, x equals 24 feet. So it's really going to be 18 feet by 24 feet in real life. So you just set a proportion, scale to actual, scale to actual. You want to keep it consistent. You don't want to flip this ratio. You want to make sure you're comparing inches to feet, diagram to real life, like that. Okay, so for 39 now, it says the triangles are similar. Find the missing side. Now what's interesting to point out here is that notice how these markings on the triangle, see these angles that correspond, they match up. See, I've got 2 marks there, 2 marks there, 3 marks there, 3 marks there. So when I match up these triangles, I know that the corresponding angles are matching up, and then the corresponding sides, the sides that match up, are going to be proportional. So in this case, we can see 4 is to 9, okay, as 3 is to x. Now notice how I'm keeping this consistent, left to right, small to large, small to large. Okay, so now if we cross multiply, you can see we've got 4x equals 3 times 9, which is 27,
divide both sides by 4, and you can see x equals, let's see, 4 goes into 27 6 times, that's 24, with 3 left over, so it'd be 6 3/4. Okay, so now for number 40, it says write the percentages, the percent as a fraction, right? So how do we convert from percentages into fractions? Well, one thing to realize is that when you talk about percent, cent means like 100, like 100 cents in a dollar, 100 years in a century, 100 feet on a centipede, right? So 32% per, remember how we said per is divided by, so 32 per 100, right? Divided by 100. So now if they do is reduce, it looks like 2 goes into both of these, so that'd be 16/50ths. 2 goes into both of these, that's 8/25ths, and that's as far as we can reduce it. So 8/25ths is the same as 32%. Okay, number 41, it says write the fraction as a percentage. So how do we go from a fraction to a percent? Well, one thing to look at is when you look at a fraction, see that division bar right there, that fraction bar? That means divided by. So 7 divided by 4. So 4 goes into 7. Let's see. Well, 4 goes into 7 once. 1 times 4 is 4. 7 minus 4 is 3. We can bring down that placeholder 0. 4 goes into 37. That's 28. Subtract, bring down another placeholder. 4 goes into 25 with none left over. So this is 1.75. Now we've converted it from a fraction to a decimal, but to convert from a decimal to a percent now, what you do is you move that decimal point 2 places to the right, and that's 175%. Now there's more than one way to do this problem. What you can also do is you can say, well, percent means per 100. So if I can get the denominator to be 100, then I've got my percentage. So 4 times 25 is 100. If I multiply the denominator by 25, I have to multiply the numerator by 25. 7 times 25 is 175%. So that's another way to do it, but I think most students like to just convert it to a decimal and then a percent. For 42, it just says write the percentage as a decimal. So now we're going the other way. So when you have a percent, to go to a decimal, you move that decimal point 2 places to the left. Now, if there's nothing there, you want to put placeholders. So this is actually equal to 0.003. Now, sometimes students get confused, and what I recommend is take like a percentage that you're familiar with, like 50%. 50% we know is a half, and you can see, so how do I get from 50% to a half? I move that decimal 2 places to the left, and I'm getting 0.5, and it makes sense. So sometimes students don't, they forget, do I go right, do I go left? Take a simple example and you'll be able to follow that same pattern. So for number 43, it says write the fraction as a percentage. So again, we've got a 5/8. We want to go to a percentage. So we would say 5 is being divided by 8. So 8 goes into 5 how many times? 8 goes into 5, 0. 8 goes into 50, let's see, 6. That's 48. 8 goes into 20. How many times? Let's see, about 2, so that's 16. And 8 goes into 40, how many times? 5. So that's a 0 remainder. So now we just have to move that decimal 2 places to the right, and we've got 62.5%. Okay, how about number 44 now? It says 40.5 is what percent of 150? So there's a formula you might want to memorize here or write down, and it's P over 100 equals is over of. So what this means is the part out of the whole, 100% is like the whole thing, is equal to what is out of the total. So you're thinking part out of the whole equals part out of the whole. Those ratios are the same. So here we have 40.5 is, so that means 40.5 goes right here, okay, of, meaning out of 150. What percent, we don't know, so we're going to leave that as a variable p over 100. So now all you have to do is cross multiply and solve. So we have 150p equals 40.5 times 100. When you multiply by 100, you just move that decimal 2 places to the right. And then if I divide both sides by 150, let's see what that comes out to. 4050 divided by 150, 27. So it's 27%. Okay, so for number 45, it says find the percent of change. Okay, so what exactly is the percent of change? Well, when you do percent of change, what you do is you look at the amount that it's changing by, so we'll just say the change, divided by the original amount. So what you're trying to figure out is how is it changing compared to what it was to begin with. So you can see to go from $12 to $20, like say somebody raises the price on something, it's going up by $8 compared to what? Compared to what it was originally, which is $12. Now if we go to the calculator, 8 divided by 12, is 0.667, okay, if I round. And then to convert this to a percentage, we're going to move it decimal 2 places to the right. So this is actually a 66.7% increase. So I'm just drawing an up arrow there to show 66.7% increase. So just remember how it's changing compared to what it was originally. Now for 46, it says find the new price, $16 marked down by 20%. Now there's a little trick to make these problems a little bit easier. If something is, let's say, 20% off, 20% discount, what percentage do you pay? Well, it would be 100 minus 20%. You're actually paying 80% of, when you think of you think of times. So we're taking 80%, which is 0.80 as a decimal, times $16. And let's see what that comes out to. So 0.8 times 16, it's $12.80. So that's the new price. The other way to do it is you could say $16 times 0.20, figure out what your savings are, and then subtract it from $16. But I find this to be a little bit easier. Figure out what you're actually paying, which is 100% minus 20%, and multiply by that quantity. You can do it in one step. Now for 47, it says find the simple interest if you have $400 invested at 2% for 3 years. Now when we talk about simple interest, here's another formula you might want to write down. It's I equals P times R times T. P stands for the principal. That's what you're putting into your investment, $400. R is the interest rate, but you want to convert that to a decimal by moving that decimal point 2 places to the left. And then T is the time, okay, in years, 3 years. So if we multiply all that together, that's going to give you how much interest that you're earning total. So we have 400 times 0.02 times 3, so it would be $24 in interest. Okay, so that's simple interest, I equals PRT. For 48 though, we're doing compound interest, and so the formula that we're going to use here is this formula, A equals P 1 plus R to the T. Now this is when you're only compounding once per year, just annually. And so in this case, that's what we have, $700. That's your principal, that's what you're starting with. And it's 3%, so that's 0.03 as a decimal. And the time is, we'll just leave it as T. So we're just going to leave this as a general formula here. So depending on how many years you have it invested at, you can calculate the ending amount by putting in the number of years. So 1.03 is larger than 1. You can see it's growing. But that would be your formula if you're just compounding once per year. So simple interest, compound interest. So for number 49, it says, is the relation a function? So what does that mean, relation and function? Well, relation is like a pairing of an input with an output, okay, a domain with a range, or an x value with a y value. So you can see with these coordinate pairs here, we have inputs paired with outputs. But not every relation is a function, okay? What you want is, for every input, you only want one output. So like if you push a button on your computer and you're trying to open a program, you don't want it to open one program one time and then open a different program another time. That's unpredictable, right? That's not a function. So what we're looking for here is our inputs 5, our inputs 2, our inputs 4, our inputs 2. Notice how 2 is repeated. One time 2 is mapping to -3, the other time 2 is mapping to 5. We have one input going to 2 different outputs. That means this is not a function, so I'm going to write no for that one. Okay, number 50, if f of x equals 2x minus 3, find f of -3. So here what they're testing us on is the function notation. And the way functions work is whatever's in the parentheses here, you put in for x on the right. Now there might be more than one x on the right, you would put it in for all those x values. And in this case, you can see f of -3, that means x is -3. So what I'm going to do is I'm going to replace x with -3, and then simplify. So 2 times -3 is -6, minus 3, which is -9. So we could say that f of -3 equals -9, and you got it. Okay, let's look at number 51. It says, write an equation that describes the sequence 7, 9, 11, 13, 15, ... and then find the 20th term. Now, this is a little bit more challenging problem, and sometimes you cover this concept when you get to Algebra 2. But let's look at the pattern here. See how it keeps going up by 2 each time? So we're going to write this as 2n, meaning it's going up by 2 each time. But let's test this out. So if I put 1 in here, you see how this 2 times 1 is 2, but the first term is actually 7? That means I have to add 5 more. Like, let's test it out again. Let's say I put 3 in for the third term. 2 times 3 is 6, but I have to add 5 more to get 11. So what I'm doing is I'm realizing I'm going up by 2, so this is 2 times something, 2 times the term that you're on, and then we have to adjust a little bit. Now there's more advanced formulas, like I said, in Algebra 2, but for now, let's just write this as our equation. We'll call it a sub n equals 2n plus 5. And the 20th term, we just have to put in 20 now, so 2 times 20 is 40, plus 5 is 45, and that's the value of the 20th term without having to keep finding the next term, next term, next term. A little bit more advanced question there. Number 52, it says find the slope. The slope is the rise over the run. Now when you think of rise, you think of up and down, and run you think of left and right. So rise is also written as change in y, run is like change in x. But you can see to get from this point to this point, I have to go down 3, so down is negative, and then I have to go right 1, 2, 3, 4, 5, 6. So right is positive. Negative 3 divided by 6 is negative 1/2. That's our slope. You could also go rise 3, that'd be a positive 3, and then left 6, that'd be a negative 6. But again, a positive divided by a negative would give you the negative 1/2. Okay, so for number 53, it says find the slope of the line that goes through these 2 points. If you want a formula for slope, you might want to write this one down. It's y2 minus y1 over x2 minus x1. Now, when you think about this point here, this is our first point, so we're going to call that x1 and y1. This is our point number 2. We're going to call this x2 and y2. The 2 just means point 2, the x and y coordinates. So we're going to do y2 minus y1 and x2 minus x1. Now, mistakes that students sometimes make is that they'll put the x's in the numerator and the y's in the denominator because they're thinking about alphabetical order, but it's the change in y over the change in x. Now, when you subtract, it's like adding the opposite. 3 minus 2 is 1, and a negative 3 divided by 1 is negative 3, and that's our slope. Now, for 54, it says what is the slope and the y-intercept of this line right here? Well, what they're testing us on here is that we really know our y equals mx plus b form of the equation of a line. This is called the slope-intercept form. M is the slope, the number that comes in front of the x. So in this case, you can see that the slope is going to be 5. I'll just circle that. And then b, that's our y-intercept. That's the constant. And that, in this case, the y-intercept is negative 1. So that's our slope and y-intercept. So for 55, it says graph the line. Now notice that this is in the y equals mx plus b form of the equation of a line, slope-intercept form. We start with the y-intercept, meaning where it crosses the y-axis, and that's going to cross at positive 4, so up 4, put a point, and then the slope is negative 1/2, which means that you're going to be rising negative 1, so it's down 1, and then running 2, like that. So again, I can repeat that, down 1 over 2, down 1 over 2, etc., etc. So that's the graph of the line there. Now for 56, it says write an equation of line. Here we're working backwards. We have to come up with the equation. Again, think about the y equals mx plus b form. The b is the y-intercept. It's crossing at negative 3 on the y-axis. And then the slope is the rise over run. Now see how it's going up 3, and then it's going right 3. So rise 3, run 3, that's going to be 3 over 3, which equals 1. So this is 1x minus 3, or you could just say y equals x minus 3. Okay, so for 57, it says write an equation of the line in slope-intercept form that goes through these 2 points. So how would you do that one? Well, first thing we need to do is find the slope. So we're going to go back to our slope formula right here. So y2 minus y1, 5 minus negative 1, over x2 minus x1, 4 minus 2. When you subtract, remember, it's like adding the opposite, and 6 divided by 2 is 3. So that's our slope. So we're going to start with our y equals mx plus b, form of the equation of a line, and we're going to replace m, which is our slope, with 3. But now we have to find out what the b value is, the y-intercept. How do we do that? Well, you can pick one of these 2 points. It doesn't matter, but you don't want to mix and match. I'll use this point here. So 5 is the y value, 4 is the x value, and we just have to solve for b now. So 3 times 4 is 12. If I subtract 12 from both sides, you can see that b is equal to negative 7. So all we have to do now is put negative 7 back in for b, and we've got it. So y equals 3x minus 7. That's the equation of our line in slope-intercept form. Okay, number 58, it says write using exponents. So we have 2 times 2 times 2 times 2 times c, 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 c. So here what they're doing is they're testing us on writing in exponent form. So we've got 2 to the 4th, c to the 5th. So this exponent represents 4 2's multiplied together times 5 c's multiplied together, and we can leave it in that form. So for 59, it says, is the number prime or composite? So what's a prime number? Well, a prime number is any number that's only divisible by 1
and itself, whereas a composite number can be divided by other numbers besides 1 and itself. So when we look at 27, 27 can be divided by 3 or 9, so this one's actually a composite number. Whereas when we look at 31, 31 can only be divided by 1 and 31. So this is actually a prime number. So good terms to review, prime and composite. So for number 60, it says write the prime factorization of the number 72. So how would you do this one? Well, what you can do is you can break it up using a prime factorization tree. So you can see 8 is like 4 times 2, 4 is 2 times 2, 9 is 3 times 3. And if you look at all these ends of the branches there, we've got 3 2's multiplied together, so that's 2 cubed. We have 2 3's multiplied together, that's 3 squared. So this is our prime factorization of 72. It's 2 cubed times 3 squared. For 61 and 62, we're simplifying, and again, we're working with the properties of exponents, rules of exponents. So how would you multiply 6x cubed times 5x squared? What would that be? Well, 6 times 5 we know is 30. But when you multiply and you have the same base, see how these are both base x, you actually add the exponents. 3 plus 2 is x to the 5th, meaning we have 5 x's multiplied together. Whereas when we divide for number 62, 18 divided by 3, we know that's 6. Y to the 5th divided by y squared, what is that? That's going to be y cubed. When you divide, you subtract. So you can kind of think of like 2 of these y's canceling with 2 of these y's, leaving 3 left over. But the shortcut is when you divide, you take the numerator's power minus the denominator's power. So for 63, it says write using positive exponents. So see how this is 4y to the negative 3? How would you write that just using a positive exponent? Well, when you see that negative exponent, it doesn't make the quantity negative. What it tells you to do is it tells you to move this quantity to the other side of the fraction bar. It tells us to take the reciprocal. So what happens is the 4 stays in the numerator, because that's not being affected by the negative 3, but the y to the negative third, that's going to become 4 over y cubed. Okay, so for 64 now, it says write in standard form. Now we're working with scientific notation, 2.1 times 10 to the 5th. Standard form just means like the regular form of a number. But when you multiply by 10 to the 5th, what you do is you move this decimal 1, 2, 3, 4, 5 places to the right. It's getting larger, so that's going to be 2. Move that one place, that's 1. And then we have 4 placeholders, which are the zeros, so it's 210,000. Now if this had been 2.1 times 10 to the negative 5th, we would actually move the decimal point 1, 2, 3, 4, 5 to the left. So for number 65, it says write in scientific notation. So here we're going backwards here. So what you want when you write a number in scientific notation is you just want one digit between 1 and 9 to the left or in front of the decimal point, and then the other significant digits to the right of the decimal point, and then times 10 to a power. So here what I have to do is I have to move this decimal point right there so that there's just one digit in front of the decimal point. So this is 1.3 times 10 to the 1, 2, 3, 4. This is a negative 4 because the negative, when you have a negative exponent there, you move that decimal 4 to the left, and that's going to be giving us the standard form of the number. Now, one thing you can remember is that if it's a really small number, see 0.000, this is a really small number, this is going to be a negative exponent. If it's a really large number, it's going to be a positive exponent. That's just one way to kind of remember. But for this one, the decimal point is right here. We really want it to be right there. We want to move it 1, 2, 3, 4, 5, 6, so that there's just one digit to the left or in front of that decimal point. So this is 4.81 times 10 to the, what did we say? 1, 2, 3, 4, 5, 6, 10 to the 6th power. Okay, for number 66, we're back to the rules of exponents. Simplify x squared to the 4th power. So how would you do that one? What's x squared to the 4th? Well, when you have a power to a power, what you do is you multiply the exponents. Sometimes students get confused. When you multiply, you add the exponents, but when you have a power to a power, you times the exponents. So how would you do this one? 3y cubed, the quantity squared. Well, when you square this, what you want to do is realize that the number also has an exponent. It's just the first power, and you distribute that power on the outside to these exponents on the inside. So this becomes 3 squared, which is 9, and this becomes 3 times 2, which is y to the 6th. So don't forget to distribute the power to the number as well as the variable. For number 67, it says, is the graph linear or nonlinear? So when we talk about linear, we're talking about straight lines. Nonlinear is just like saying it's not a straight line, it's not linear. So what do you think for this one? Well, you can see it's like more of a curve, it's not a straight line, so we would say this one is nonlinear. For 68, it says find the square root. So you recognize this radical here, the square root symbol? This tells us what number times itself is 36. So in this case, you can see 6 times 6 is 36, and then times that negative will make this -6. So you work from the inside out. For 69, it says estimate the square root. So square root of 83, what do you think that would be approximately? Well, we know that the square root of 100 is 10, because 10 times 10 is 100. We know the square root of 81 is 9, because 9 times 9 is 81. But 83 is closer to 81 than it is to 100, so I would say square root of 83 is approximately 9. Okay, so we're just rounding to the nearest integer. For number 70, it says find x. So you can see they give us a triangle here. What do you think? How would you solve for the measure of angle x? Well, the thing to remember is that triangles, all the angles add up to 180, whereas with quadrilaterals, four-sided figures, the angles add up to 360. So in this case, let's see, we've got 88 plus 32, so that would be how much? That'd be 120, so that means that x has to be 60 degrees. Okay, let's go to number 71. It says classify the triangle by its sides and its angles. So you can see that there's two sides that are the same. See these marks right here? That means that they're congruent, they're the same length. If two sides are the same, we call it isosceles. If all three sides are the same, we call it equilateral. If they're all different length sides, we call it scalene. But for this one, it's definitely isosceles because exactly two sides are congruent or equal. And when you look at the angles, you can see that two of the angles are 15 degrees and one angle is 150 degrees. Now, if one angle is greater than 90, then we call it an obtuse triangle. If one of the angles was 90 degrees, we call it a right triangle. If all the angles are less than 90 degrees, we call it an acute triangle. And if all the angles were 60 degrees, we'd call it an equiangular triangle, meaning all the angles are equal. So for this one, I would say isosceles obtuse or obtuse isosceles, either one. Before we do these last 5 problems, I hope you've been enjoying this pre-algebra review. If you want to take your learning deeper with me, check out my Algebra 1 video course for sale. I go through a typical Algebra 1 curriculum with teaching, we go through the different concepts, the formulas, and we go through numerous example problems, also with additional example problems that you can practice on your own to really master Algebra 1. So check out the course. Let's go through these last few examples and we'll wrap up this video. Number 72, it says find the missing side. So you can see they're giving us a right triangle here. And when we see a right triangle, we think Pythagorean theorem. So the famous Pythagorean theorem looks like this. It's a squared plus b squared is equal to c squared. Now a and b are the two sides that make up the right angle, whereas the c is the longest side. It's the side across from the right angle. So if we substitute in what we have here, we have 6 squared plus x squared equals 10 squared. 6 squared is 36. 10 squared is 10 times 10, 100. If we subtract 36 from both sides of the equation, we get x squared equals 64. And if you take the square root of both sides, you're getting x equals 8, and that's the missing side. Okay, so for number 73 now, it says find the area of the trapezoid. And remember, a trapezoid is when you have a quadrilateral with exactly one pair of opposite sides parallel, but these sides are not parallel. Remember the formula for area of a trapezoid. It's 1/2 times the height times the sum of the two bases. Now the two bases are the two parallel sides. In this case, it's going to be 8 and 10. And then the height is the perpendicular distance between those two parallel sides. In this case, it's 4. So if we simplify, you can see we're getting 18 times 4 times 1/2. 1/2 times 4 is 2. 2 times 18 is 36. So this is going to be 36 centimeters squared. So area is units squared. So you might want to write down that area of a trapezoid formula. For 74, we're working with a circle, and we want to find the circumference, which is the distance around the circle, and then the area, that's of course the inside of the circle. So a couple more formulas you want to remember. Circumference is 2 pi r, so 2 times 3.14, which is pi, times the radius. And the area is equal to pi r squared, so the radius squared. So for here, the circumference, 2 times the radius would be 2 times 4, which is 8, times pi, so that's going to be 8 pi meters. But the area is pi times 4 squared. 4 squared is 4 times 4, which is 16, so we get 16 pi meters squared. For 75 now, it says find the mean, median, and mode. So we're kind of talking about statistics a little bit here. Mean means the average, median means the middle, and mode means the one that occurs the most. But when you do this, you want to write the numbers in order from lowest to highest. So I just rearranged them from low to high.
So when we think about the mean is like the average. So we have to add all these up and divide by how many we have. So we have 5 plus 6, which is 11, plus 7, which is 18, plus 7 is 25, plus 10 is 35, divided by 5 numbers. So you can see that the mean is 7. Okay, now for the median, that's the middle number. So we have 5 and 10, 6 and 7. 7 is the one in the middle, so that's going to be our median. If there's two numbers that are in the middle, then what you would do is you would add them together and divide by 2. So it's like an average of the two middle numbers. And the mode is the one that occurs the most. So you can see there's 2 7s, so the mode is 7. So it looks like all of our answers came out to 7. Now, if there was 2 7s and 2 6s, then the mode would be 6 and 7. Say, for example, if all the numbers were listed just once, then there would be no mode. Okay, and for number 76, it says, what is the probability of drawing a red marble? Well, when we talk about probability, we're talking about the number of successful outcomes, or I'll just write the number of successes, divided by the total possible outcomes. So if we reach into this hat, blindfolded, right, we say, what's the probability we pick a red marble? Well, there's 3 red marbles, so 3 chances of picking a red marble, a success, divided by 5 marbles total, so our probability is equal to 3/5. So you got this. If you want to see my Algebra 1 giant review, check out the video right there, and I'll see you over in that video.